Exponents?
Negative exponents. Thank you. What happens when the exponent's going to be less than 0? Again, watch for patterns. It's all about patterns.
I fundle this every time, even in the pretest. I always confuse negative exponents.
Mm-hmm.
Same.
Here's a tip for you guys. Negative exponents come up a lot in algebra 2. So that's why we've seen them before maybe, and we're gonna focus on them more now, is because there's a lot of things that happen in math with negative exponents. And so right now, your purpose is just to be able to simplify with them. Later, when you get to algebra 2, you'll be doing more things with negative exponents.
Negative exponents turn into fractions, right?
Yes, but they get so confusing in big problems.
They're always 1 over whatever that digit is.
Yeah, I knew that, but like I still got confused.
Yeah, so that's the pattern we already know, right? To the power of 6, to the power of 5, to the power of 4, 3, 2, 1, 0, and it's going 64, 32, 16, 8, 4, 2, 1. So, and Mahi, I like the way you set that up in the chat. So, remember, we were dividing, right? We were dividing by the base. We divided by 2, we divided by 2, we divided by 2, we divided by 2. And so we're at, what are we at now? 1? So what do you think 2 to the power of -1 is going to be?
1 over like 2.
Because you divided by 2. 1 divided by 2 is 1/2.
Yeah, if any digit is to the power of something less than -1, it's going to be 1 over that digit multiplied by.
So literally just like taking the negative and then converting it into a 1 over and then solving regularly, pretending that the negative wasn't there.
Sorry, negative. What I'm trying to say is it would be 1 over -4 times 3, because that's the power.
So let's add those ideas to our notes. I'm going to do my best to capture kind of what you guys were thinking about. We have 2 to the power of 2, and I'm not doing the whole pattern on the screen there. There's just part of it. 2 to the power of 2 is 4. 2 to the power of 1 was 2. And then if we go 2 to the power of 0, we divide by 2, right? So we get 1. And then if we go to the negatives, we're now taking our answer and dividing by the base. So 1 divided by 2 is 1/2. What happens when we divide 1/2 again by 2?
It would be 1/4.
Get 1 over 4.
So it just keeps going. Okay.
I don't understand like why that happens.
Well, and so I heard you guys say a couple of things. One, I heard you say that this is also just 1 over 2 to the power of 1. This is 1 over 2 to the power of 2. Okay, so if you get this negative exponent, sometimes some of you might think it's just easier to do it like this. And so then you're able to get to your answer. Will that be 8, I think?
Wait, why is that 23?
I've been over this like a billion times, but I've never bothered to take notes, so I forget every time.
And there is a advertisement for, please guys, take notes with this lesson. It's gonna be helpful.
When I do this, I don't. When I do this, I don't put the exponent there. I just I elongate it, so it's gonna be 1/2 times 1/2 times 1/2. I don't like using exponents and fractions.
And
it's just, for me, simpler. Instead of having to calculate what the exponent is, I can just simply just multiply. If it's a long number, then I'll have to resort to exponents, but otherwise I'd rather just write it out.
Mm-hmm. And so that got to like the idea of why. So people were asking, well, but why?
But
right?
why what?
Well, what if your base and your exponent is negative? I got really confused on that, even though we've probably known.
So let's do another example then. Let's take -3.
-3 to what power?
Well, we're going to just follow the pattern out and we'll talk more about the why. So -3 to the power of 1, -3 to the power of 0, -3 to the power of 1, -3 to the power, or -1, sorry, -3 to the power of -2. So that's just going to be -3.
The next one's just going to be 1.
If we go -3 divided by -3, we get here. That's 1. If we
And
go,
then 1 over -3.
yep, 1 divided by -3, right? And this is going to be, well, now we have negative 1/3
-9.
divided by -3. So the pattern still holds up. If the exponent is odd, we get a negative answer. If it's even, we get a positive answer. And what we're doing is we have, this is the base. We're dividing by the base every time as we get into the negatives. I'm trying to think what kind of example I want to give you. Let's talk about a shortcut way, a way that maybe will help you remember this if you don't have your notes in front of you. So this is why it's happening. You're dividing by the base every time. Here's a shortcut. If the base moves, I'll write it and I'll show you what I mean. If the base moves over the fraction bar, the exponent changes. That's what's happening here. That's like kind of the shortcut way to remember it. I'll show you what I mean. If we have x to the -4, well, let's just make that over 1. If I take this and I move it down here, well, the exponent's going to change. I don't know if that helps at all. We can do another one. If we had 5a to the -2, well, what I could do is I could move it across the fraction bar. And I only need to move the a. It's the only one with the exponent, so I can leave the 5 there. And if you move it,
Didn't the A need a parentheses or no?
yeah, you could, like that. So if you have a number with a negative exponent, well, if you take it and move that power across the fraction bar, then you'll get a positive exponent.
I find it easier if we just do a positive exponent on the bottom, over below the 1.
See, it does get confusing very quickly. All right, we've done a lot today. We've done zeros, we've done negatives, we've done positive exponents. I want to give you one more shot at just kind of some practice to see how we're doing, and then we'll give you the homework, okay? So,
Do we always have to? Oh, wait.
choose column A or column B, or do both. Go ahead and try these columns out. So the directions always say simplify. Get to an answer if you can. Mahi, your example in the chat is a fraction with an exponent. That's going to be a whole nother conversation. We're not going to talk about it today. We already have a lot going on. We don't want to add another thing to our plate right now. So here's a bunch of problems. Notice we have negative exponents now. You can make them positive by moving the power across the fraction bar. We have 0 exponents. we have just normal numbers too, constants.
But what if it's already on, like the negative exponent's already on the bottom of the fraction bar?
Oh, that's a great question. So one cool thing in math is we don't like negative exponents. All mathematicians agree they're no fun. So if there's a negative in your problem, you need to get rid of it. And just use the shortcut. So if the exponent's negative and it's in the bottom, well then take the power and move it across the fraction bar. That way it becomes positive. So like I'm looking already at like column A, problem 1. The t has a negative exponent. So what we're going to do is we're going to take that t, move it to the top, to the numerator, and then that exponent's now positive.
Oh, so you just move it to any side. It doesn't matter if it's bottom or top.
Whenever it crosses the fraction bar, the exponent changes.
So like you move the t and then you like by moving it across you get rid of the negative part, but you also move it along with the cube.
Mm-hmm.
Okay.
So would we just switch? Would it, like, if we were just gonna switch and we were getting rid of the exponent, would their answer be 7t to the power of 3 and then 5 like s to the power of 2? Would we just switch it, the s and the t?
Mm-hmm.
We would?
Yep, that's it.
Yay!
And you know what? I think what I'm going to do as you guys work these out, I think I'm going to just show you the answer here too, so that you can kind of see it as we go. So like you just said, there was that answer to problem 1 on column A. So whenever there's a negative exponent, we just need to take that power and move it. If the number is fine the way it is, just leave it alone. Like in column B, there's a y on the bottom and it's fine just leaving it there. And then always remembering, if you have numbers out in front and you can divide them, divide them. The 7 and the 5 in the first problem, they don't divide evenly, so we just leave it as 7/5. But the 21 over 3, we can divide that. Hopefully you're feeling a little bit uncomfortable now. We've gotten to like the really kind of the new stuff right here. So today we did a lot of review with exponents and we looked at patterns and we talked about what do we remember with the 0, and then we went into the negatives, and now we're dealing with all of them together. And I need to make sure I give you more practice with this. And that's what the homework's going to let you do. It's going to take problems like this and have you try it on your own. And then when we come back together next time, we'll correct it. And we'll talk about any that were confusing. So those are your answers. Are there any questions? I want to launch a poll real quick, fist to 5. I want to see kind of how you're feeling now that we've reached the spot.
So I have a question.
Go ahead.
Anytime we're dividing numbers, like what I got for column A second problem is I didn't get rid of the 21 and 3. So my answer looks like 21 times G5 times 9/3 over 3 times B1. Do we just divide once we get to that stage? Just divide like the numbers like normally?
Yeah. The more you do that, the more you will see that. Like what I do when I do these is I solve the whole problem, and then that's the last step at the end is I look all the way to the left and I see, oh, there's a 21 and a 3. Let me go ahead and divide those. All right, thank you. Those of you that answered the poll, fist to 5. I want to know if 1, you feel like you got it, or 5, you're lost, kind of how you're feeling so far. We'll give you the homework here in just a second. If you get stuck on the homework, if you want some help, stay on Zoom, or you can always email for help too. Your homework is going to look a lot like these ones that we're doing right now. Okay. Mrs. Flood, can you tell us the homework, or can you turn it on in Schoology for us?
I can do that. I will put it into the chat and I will turn it on in Schoology.
Cool. Yes, you can use calculators if you want. At the beginning, I showed you how to use a calculator for exponents. I don't know if you'll really need them, but they're there if you need them. Okay, so your homework's going to be a handful of problems. It says simplify. That's what we're doing right now. Sometimes you get to an answer. Sometimes you're left with like what these look like, fractions with variables in them still. So there's your homework, page 417. You're gonna skip around a bit. You're gonna go 13, 14, 19, 20, 23, 24, and
We
then
can't see the homework. We see the slideshow.
let me stop this. The homework is in chat.